lecture number 20. Actually, in today's lecture, we are going to study also a new rules for Laplace transform. Uh, to explain what I'm going to study today, let me first do one revision for the Laplace transform of y prime. Do you remember the rule of Laplace transform of the derivative of your function, or Laplace transform of f prime? Do you remember? It's given to be sy capital minus y of 0. And here s of f capital minus f of 0, f small of 0. So we depending on this rule, we can find the Laplace transform of the derivative of my function. In today's lecture, if you have Laplace of your function f is given to be f capital of s, and now I need you to differentiate this. So today we are going to learn how to find a derivative of the function f capital of s with respect to s. So derivatives of the transforms or Laplace transform. Here the objectives. Now, what is the objectives? Here's the objective of our lecture today. And before we start a new ideas, let us do some revision about what we studied from the beginning of Laplace transform. Actually, we studied how to find Laplace transform using the general definition, this one. It's given by the integral from 0 to infinity, your function times exponential. By the way, you can use this t and this t as tau. You are free as beta. What I need that this and this and this is the same. So tau, t, beta as you need. All of them the same definition. We studied the derivative, the Laplace transform of the first derivative and second derivatives. Those are very important to solve initial value problems. Then we moved to study the Laplace transform of a product between two functions. One of them must be the exponential. We call this rule the first shifting or translation theorem. And we have its inverse here. Then we moved to find the Laplace transform of a product between two functions. One of them is the unit step function. And we call this second shifting theorem, which you have here shifting on t-axis. And we studied its inverse in this formula. Don't forget also we studied two tables, one for Laplace transform and the second for the inverse Laplace table. In today's lecture, we are going to check how to find derivative of the Laplace transform. I have the following theorem now, which we can prove it easily together. So now I need you to check, show that the derivative of Laplace transform is given by this formula. Let us do that together now. Here in this slide, I'm going to start proving this rule. Now let me start from the left-hand side. So my left-hand side here, left-hand side is given to be a derivative d over ds of f capital of s. What do I mean by f capital of s? What do I mean by f capital of s? Yes.
Laplace of f of t.
Yes, Laplace of f of t. Laplace of f of t. You are right. And what do you mean by Laplace f of t? What do you mean by this Laplace f of t?
Integral from 0 to infinity.
So you are right, but let me just 1 minute. So it is integral. It's integral from 0 to infinity, e to the negative st, f of t dt. Now you have differentiation and integration. Can we cancel them out, and why? What do you think? I know that the differentiation is the inverse of the integration. So can I cancel those together now, or I can't?
No, we can't.
Why?
Because they are not with respect to the same value.
Yes, the integration with respect to t and the differentiation with respect to s. So no relation between this differentiation and this integration. So, Professor, how to differentiate an integral if I have two variables? You can interchange between the integration and differentiation. So I can write equal integral first from 0 to infinity, differentiation with respect to x. But now I'm going to write partial derivative because inside function, the integrand function has two unknowns, s and t, and I need to differentiate with respect to s. So here e to the negative st times f of t dt. So I need to differentiate this function times dt. Now don't forget your differentiation with respect to s. So this f of t can be considered as a constant because no s here. So leave f of t. How to differentiate e to the negative st with respect to x is it's very easy. Multiply by the coefficient of s up. So equal integral from 0 to infinity. Now the differentiation of e to the negative st with respect to s, it is negative t times the same function e to the negative st times ft, it is a constant with respect to t, all of them times dt. Now only what I'm going to write to take this negative out of the integral. And I'm going to write as the following from 0 to infinity e to the negative st first times t times f of t. Can I do that? Only I multiplied the t by f and the exponential first. Now, what do you think about this integral? Let me consider t times f of t as a new function. Let me call it g of t. So now I have negative integral e to the negative st times gt dt. What do you think about the last integral? Last integral. It's a famous
Laplace of
Laplace.
g of t.
You are right. Laplace of g of t. Laplace of g of t. Go back, please, to your g. I don't know g. So it's negative Laplace. Your g, it is written here to be times f of t. So the new rule, which you need to add to your cheat sheet, is this one. The derivative of Laplace transform is given to be negative Laplace of t times f of t. And also for me, I can write the following rule here. I can say Laplace of t times f of t is given to be negative first derivative of Laplace f of t. What do you think about this rule? It's the same like this. It's the same. Multiply by minus both sides, and instead of f capital, I wrote f of t. So today, the new rule, it's Laplace transform of a product between two functions. Notice t times f of t. The first function must be t or t squared, as we are going to see now in the coming slide, t to the power 3 and so on. So we studied three special cases of a product between two functions. The first one, exponential. Second one, unit step. And today, new rule, if I have t squared, t to the power 3, and so on times my function, I can find the Laplace of this product. But if you have maybe Laplace of sine t times your function, for me, I don't have a rule. I'm going to apply the integration formula. But if one of those exponential unit t squared, t to the power 2, 3, 4, and so on, I have a specific rule. Okay? Here's the general formula now. If you have, notice now, if you have, just 1 minute, if you have t to the power n times f of t, not only t to the power 1, t to the power n, and you need to find Laplace transform of this product, so it's negative 1 to the power n, the same n. Differentiation of order n of your f of t, Laplace f of t. Okay, let me write here the rule for t squared. Let us check. Can we do that? So I need now Laplace transform of t squared times f of t. What do you think about this? Apply the rule, please. Your n is 2 now. So what should I write?
-1 squared.
-1 squared, okay, times
second derivative of
second derivative of
capital S.
Laplace of t, or capital F of s. You are right, because capital F of s it is Laplace of t. And also, if you need to check Laplace transform of t to the power 3 times f of t, it's very easy. Apply the rule. Apply the rule. -1 over -1 to the power 3, third derivative with respect to x of f of s. So this rule is very easy and very important also. It will help me to solve some differential equations, and those differential equations can't be solved using any one of the previous techniques, which we studied in chapter number 4. Let me check if I have a problem now here, and together try to do it, then I'm going to solve an initial value problem. So now, let us try to find the Laplace transform of this product. For me, before today's lecture, if I need to find Laplace transform of this function, I'm going to do the integration formula. So you have exponential times t squared times cosine. Maybe you need at least half an hour to finish the integration. But using today's rule, I can do that in 1 minute or 2 minutes. Let us check how to do that. So now I need you to find Laplace transform of a product between t squared times cosine 2t. For me, it's very easy. I'm going to apply the rule here down. It's given to be -1 to the power 2, second derivative with respect to s. Don't forget Laplace transform of my function, which is cosine 2t. It's very easy rule. You have to memorize it. You have to write it in your cheat sheet. Please, as I told you yesterday, you have to prepare your cheat sheet starting from now. And yesterday, I sent you a paper in WhatsApp, which I'm going to attach to your papers in the final exam for who will take the face-to-face exam. And please, I ask you to remind me 4 days before the final to attach this paper to your exam. So now equal -1 squared, it is 1 squared. So I need to find second derivative with respect to x, to s, sorry, of Laplace cosine t. For me, Laplace cosine of t from my cheat sheet is given to be s divided s squared plus 4. So for who practice a lot to solve problems about Laplace transform, they will do the problems in the exam quickly and finish the exam before the 2 hours end. But those who didn't practice how to use the rules, maybe they can't finish all the problems in the exam. So take care, please. Now I need to differentiate this function twice with respect to t. With respect to x, I'm so sorry. Let me first find the first derivative. Okay? For me, I forget how to find the differentiation of a fraction. Can anyone of you remember how to differentiate a fraction? Or should I ask? Who need to help?
It's the
Differentiation of the denominator, yeah, doctor.
Differentiation of the denominator, okay.
Multiplied by the numerator.
Okay, continue. Only? Then?
Differentiation of the numerator multiplied by the denominator.
And what is the sign between them?
Minus.
So could you please repeat in details?
تبقى 2s يعني.
Yes, 2s. Okay, I understand. 2s times s. You are right. So differentiation down times up. I understand. Continue, please.
s squared plus 4 s.
No, you have to say the sign. I can't write anything unless if you say it.
Minus.
So here the minus or here the minus?
لا to the left. أيوة كده. Yes.
To the left. But you said in the opposite way, okay? Take care, Omar. So also here now, differentiation of up, which is 1 times the denominator s squared plus 4. So it is differentiation up times down minus differentiation down times up. And what about of my denominator?
Squared بقى.
Yes, squared plus 4 or squared. This is the first derivative. Now I'm going to find second derivative, okay? But here 2 times s, it's negative s squared. and here plus s squared, so I have only one negative s squared. So d over ds negative s squared plus 4 divided s squared plus 2 plus 4 all squared. Now also I have a fraction, the rule of the fraction, my denominator it will be squared, so s squared plus 4 squared all squared up, it will be differentiation up negative 2s times down s squared plus 4 all squared minus differentiation down. How to differentiate this fraction, this denominator, this bracket, s squared plus 4 all squared? How? Yes.
Take the power
Take the power
be
down. Yes.
2
Yeah.
s squared plus 4
Great. Times?
2s.
Times 2s. Great. And don't forget to multiply by your numerator. So it's negative s squared plus 4. You can distribute the bracket and find the simplest formula. Okay, did you get the idea now? If you have a product between two functions, one of them is t or t to the power 2, 3, 4, and so on, you have to differentiate with negative 1 to the power n. Now, what I'm going to do is to solve an initial value problem. But let us discuss now. Please forget Laplace transform and let us go back to chapter number 4, which we studied how to solve differential equations of second order. I need one of you to help me now to solve the given differential equation using the previous techniques, not Laplace. How to solve this equation. You have to participate, please. When you try to participate, you will understand more. So guess, please, which method will help me to solve the differential equation? Any idea? I'm waiting you.
Annihilator method, doctor?
Yes, let us check if we can do the annihilator method. For me, I remember if I need to use the annihilator method to solve the non-homogeneous equation. So first step is to find yc, which is the solution of the homogeneous. And second step is to find yp. And how to find yp? By applying the annihilator of the right-hand side. Then I'm going to say that y equal yp plus yc. Great, great. So here you said the YC. What is the annihilator? Marwan is speaking. What is the annihilator of your right-hand side?
D.
D. Yeah, we are right. Great. This one is nice. How to find YC now? How to find YC?
Equated to 0.
Solve the homogeneous. So I'm going to write here. Great. So to y double prime plus t y prime. Excellent. Minus 2y equals 0. I equated it to 0. Then how to find the solution?
The auxiliary equation.
The auxiliary. Could you please help me to write the auxiliary? So it's 2
m squared.
M squared plus. Continue, please.
There is a tm.
Tm, yes. Plus minus.
Minus 2 equal
2
to.
equals 0. Now, what are you going to find now after writing the auxiliary? What do you want me to find?
The m, but I didn't notice the t.
Yeah, unfortunate.
Yeah.
We have here t.
I didn't
So
notice
you can't use the auxiliary technique because your differential equation with non-constant coefficient, so you can't use the annihilator at all. You can't use the annihilator.
Yes.
Yes, another methods. Any idea? By the way, because this equation is non-homogeneous, so in all the materials or the theorems or the ideas in the previous chapter number 4 is to find first a yc, then find yp, then find the summation. Who can help if you have non-constant coefficients? Which method can help now?
Variation of parameters.
Let me check. Variation, great. Variation of parameters. For variation of parameter, you will find yc, yb. I remember, so no d here. No d. I remember, no d. No d at all here. The yb, I remember. Do you remember the rule of yb, Muhammad? U1? Yeah. If you remember, it's u1, y1 plus u2,
Plus
y2.
u2, y2, yeah, doctor.
Yes. Now, I know that you will find U1 and U2 using Roninsky determinant and the grammar rule. But what about of those Y1 and Y2? Those I forget them. From where you will find Y1 and Y2?
هو
Those are
كان
what?
المفروض نجيبها بالاسمه ده من الناحيه الشمال، بس هي مش مديها لنا، واحنا مش هنعرف نجيبها بالاكسلري ايكويشن، فمش هنعرف نستعمل.
Yes, you are right. Look, so Muhammad now said, no, unfortunately, also the variable order, sorry, the variation of parameter method can't help me because I need to find here y1 and y2, the solution of the homogeneous equation. So 2y double prime plus ty prime minus 2y equals 0. Unfortunately, I can't use m. So also the variation of parameter can't help. So what do you think now?
Can we try the reduction of orders?
Yes. Who is speaking now?
Ahmed.
Ahmed, yes. Could you please tell me the rule of reduction of order? Or the substitution which you need to use? For me, I remember the reduction of order solve the problem using this substitution. Y equal uy1. What is the uy1? What is the y1? It's the one solution of the homogeneous equation equals 0. Do you have y1? Do you have y1? No, unfortunately. Also, I can't find y1. Usually, I will give you y1. If you remember in the exam, I ask you to prove that y1 is solution, then solve the second one and you use the reduction of order. But now, I didn't give you y1. So also, reduction
but I
of order.
can't find any solution for this because the auxiliary won't work. I can't think of another method.
Could you please repeat? You can. Yes.
What method can we use? The auxiliary won't work to give us any solution to begin with.
Yeah, if the auxiliary can't help me, so which method should I use? This is your question?
Okay.
Yeah, for me, I have two different methods. The first one is to guess one solution. Okay, I can guess one solution. Professor, I don't like this method in the exam because all the students will be worried, not comfortable how to guess, so we don't need the guessing. So, Professor, how to solve this problem now?
Can we solve it using the homogeneous technique, Doctor?
No, at all, because this. What do you mean by homogeneous? That y equal or u equal y over x? This is your idea, or what do you think?
Yes.
No, at all. This for first order, not for second order. Okay, so we can't use this. Oh, so I think all the techniques which we studied in the previous chapter can't help. We must solve this equation using Laplace transform, unless if you guess one solution for this equation. If you prefer to guess, so please do that. If you don't like guessing like me, so you must now solve Laplace transform. Use Laplace transform. So the idea of Laplace transform that there are some differential equations that you can't solve them using any one of the previous techniques, and the Laplace transform will solve them easily. Did you get the idea? So in the exam, we'll find similar to this equation, but I'm not going to ask you solve it using Laplace transform. I will write like here, solve the following IVB, initial value problem, with those two initial conditions. You have to notice that my equation, unfortunately, with non-constant coefficients. So you can't use the auxiliary, you can't use the annihilator, you can't use the variation of parameter, you can't use the reduction because you don't have the first solution. So immediately I'm going to use Laplace transform, but take care also. Laplace transform can't be used if you don't have initial condition. So in the exam, if you have only this differential equation, and here not IVB, it's DE, with no initial conditions, you don't have those. So here you can't use Laplace. You have to solve this equation You have to solve this equation using one of the previous techniques. But at that time, I'm not going to write here t, or I will give you y1. Okay? So if you don't have initial condition, please try to think in one of the techniques in chapter 4. If you have initial conditions and the equation with non-constant coefficients, so Laplace will solve. Clear now? Can I start solving this problem? Let me begin. Where is my pen? Here in the black slide now, together. But please now write your names. All of you, please write your names. And let us together do the solve this problem. Here the solution. I'm not sure how many slides do I have. I have 2. So here the solution. For me, first step to solve differential equation using Laplace transform is to take Laplace for all terms in your differential equation. So I have 2. Could you please help me? 2 Laplace y double prime plus. So here I wrote the t outside of L because it's a constant. You can do that for t. T is unknown. So Laplace of t y prime minus 2 Laplace of y equal Laplace of 2. I have my cheat sheet. The rule of Laplace y double prime is given to be s squared y capital. By the way, y capital of the variable s minus sy small of 0 minus y prime of 0 from my cheat sheet. Yeah, now what about of this Laplace of ty prime? Can I write Laplace of t times Laplace of y prime, or do we have a rule to find Laplace of a product between two functions? One of them is t. So Laplace of t to the power n times f of t times anything equal to the -1 over n derivative of order n with respect to s of Laplace of t. This is a new rule which we studied today. So please, Laplace need your practicing. Let us continue now. Here, can anyone help how to write Laplace of t times y prime? Help me, please. Using this rule.
-1.
Okay.
dt by ds.
d by ds of what? I need the black. Just
Laplace y dash.
Laplace of y dash. Great. Continue, please. So I have here. What about of Laplace y small? So -2. Laplace of y capital. Great, Muhammad, equal Laplace of 2. It is 2 over s. I know this. Now for me, I'm going to plug in the y0 and y prime 0. So this is 0 cancel. This is 0 cancel. So I have 2 s squared y capital. Don't forget that your y capital is a function of s negative d over ds of Laplace y prime. Laplace of y prime. It's a famous rule. It is s of
sy
yes,
minus y0.
You are right. Y of s. So y of s. No need to write of s. Only y capital as you need. Minus y of 0. You are right. Minus 2y capital equal 2 over s. Yeah. Now what I'm this is 0 cancel out here. So let me write. What do you want me to write? I'm going to just leave this. So this one nothing to do here. Minus here you have a derivative with respect to s of this product s times y. How to find the derivative of s times y? How to do that? How to find this?
Product rule.
Product rule, yes. Derivative of the first one times the second, it's y capital, plus the first as it is, a derivative of the second, a derivative of y with respect to s. So dy capital over ds minus 2y capital equal to over s. Am I right here? Yeah. What I'm going to do, let me. Sorry, I need to Just a minute. What do I need? Nothing. Let us continue here. I'm going to multiply this minus inside. So it's 2 s squared y capital minus y capital minus s dy capital over ds. Am I right here? Minus 2y capital equal 2 over s. Great. Now this with this are the same. So negative 3. Negative 3. So let me write in details. So here 2 s squared y capital minus 3y capital minus s dy capital over ds equal 2 over s. I'm going to write here in so here, I'm sorry, I'm going to write here. Okay. So go up here. So what should I do now? I'm going to take y capital common factor here. So here I have 2s squared minus 3 y capital minus s dy capital over ds equal 2 over s. To make the problem easy, I have one question. Do you remember second step? So here first step is to apply Laplace transform for all terms. What do you think about second step? Do you remember second step when I try to use Laplace transform to solve initial value problem?
We divide by the coefficient of y's and take Laplace inverse. بس دلوقتي المفروض نحرك الناحية التانية الأول.
Yes, 1 minute. 1 minute. I think you missed only one small sentence. Can anyone help? Second step. What you said is fully right, but I need in a small sentence. Usually, I said it before dividing and take to the left hand side.
Put the Laplace.
No, this step is after.
Move the s dy over ds.
I need you to say sentence. Second step is what? Do you remember? What you said is right, but usually I say first step take Laplace for all terms. Second step. Do you remember what I say usually?
Isolate y.
Isolate y. Find y capital. Can anyone help to find y capital alone? Where is y capital? Professor, I have two y capitals. This y capital and this y capital. Can you take y capital common factor? No, because this is a derivative here. dy over ds, it's a derivative. You can't take y capital common factor. For those who said, Professor, now divide by the coefficients of y capital and move s dy over ds to the left, to the right hand side. Unfortunately, your right hand side contains y capital. I need one y capital to be in the left hand side.
Do we integrate the entire?
Yeah. So now you have maybe you almost right now. Now we have a derivative of y. So I have differential equation. So this with y capital, it's a differential equation. I have equation and I have a derivative of my unknown y capital. That means I have differential equation. To find your y capital, you must solve this differential equation. How to solve this differential equation? Let me write the derivative first. So this equation can be written in negative s dy capital over ds plus 2s squared minus 3y capital equal 2 over s. Help me to solve this differential equation.
Is it first order linear?
Yes, you are right. So it is first order linear dE, differential equation. So this differential equation or this problem here from the beginning of our problem, it's very important because you solved the first one using Laplace, it's moved you to first order linear. So if I have similar to this equation in my exam, so instead of asking you two questions, solve using Laplace and solve first order linear, I'm going to ask you one problem and you must use Laplace and you must use also first order linear. Now, to solve using first order linear, let us first divide by negative s, if you remember the steps. So I have dy over ds plus or minus, because you divide, let me divide by minus, okay, minus s. So here minus 2s squared minus 3, all divided by s, y capital, equal 2 over s squared. Where is your f and where is your p? Because I remember I need the f and p. This is my p and this is my f. And for solving first order linear, I think first step, so notice here in circle, not like the yellow one in square. I remember first step is to find the mu of s. I'm not sure if I'm right. You have to check. So it is e to the exponential. Exponential of what? I forget. Who can help? Exponential of what?
It will be the integral of negative 2s squared
Yeah,
minus
so it's
a over
negative,
s.
it's bs, you are right, it's bs, great. So e to the integral of negative 2s squared minus 3, all divided s ds. How to find this integral? How to find this integral?
We separate them and into two.
Separate, yes, you are right. So e to the integral negative, separate, so now I have negative 2s minus 3s, 3 over s, all ds. Am I right here? Because I here negative, I'm sorry. I cancel the squared with s. So I have e to the integral. No, I can now find it as negative s squared. Negative s squared plus or minus 3 ln s. Can anyone give me the answer here? The simplest form, it is e to the negative s squared times what? Help me please. Times what?
S to the negative 3.
S to the negative 3. S to the negative 3. You are right. By the way, I think I did something wrong. I here did a small mistake, a tiny mistake. Can anyone find it? It is plus 3, great Selma. So here minus, so it's negative 2. And this minus will make your plus 3 instead of minus 3, plus, 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 and plus. Don't forget your mu s. Second step here in the black slide. Second step is to write mu s times y of s, y capital, my unknown, equal integral of my mu of s times f of s. F of s. So I have the following now. Mu of s, I found it to be e to the negative s squared. Let me check. It is what? E to the negative s squared, right, times s to the power 3 times y capital equal integral of e to the negative s squared times s to the power 3 times my f. Where is my f? It is 2 over s squared. 2 over s squared. I think it is negative 2 over s squared. It must be. I multiplied here by negative s, so it's negative. I'm so sorry for this mistake. It's negative. I'm sorry. Just 1 minute. Give me 1 minute. It must be negative s squared. Negative 2s divided s squared. I'm sorry. Continue here. Negative 2s squared ds. I can cancel out s squared with this s. So I have integral of negative 2s e to the negative s squared ds. Those are those. How to integrate this function? Negative 2s e to the negative s squared will help to integrate this function. It's very easy, by the way. Can anyone speak?
U equals negative s squared.
Yeah, let me use, let u equal negative s squared. That will give me du equal negative 2 s ds. that will give me ds equal du over negative 2s. And by the way, for me, I found here up negative s squared, and its derivative, it is negative 2s. So the integration, it is e to the negative s squared. But by the way, no need to do like what I'm doing now. You can use this substitution, is fully right. We go to the diagram. So now I have here e to the negative s squared s to the power 3y equal integral of negative 2s e to the u times du over negative 2s. Cancel out negative 2s and negative 2s. So you have only eu plus c, which is e to the negative s squared plus c. Now I need y capital. Don't forget that. Let me go back to the yellow and write my second step. My second step is to find y capital equal, you need to divide by those. So it is e to the negative s squared divided by e to the negative s squared times s to the power 3 plus c divided e to the negative s squared times s to the power 3. This can be written as the following. Cancel out this with this and take this up. So you have 1 over s to the power 3 plus c times e to the s squared over s to the power 3. You are right. Now I can take inverse Laplace for both sides, but I have here the constant, and we are solving initial value problem. And unfortunately, the initial for y small, I have some difficulties here. Let us as usual find the inverse Laplace for all terms. So we will write now inverse for this, which is y small, and inverse for this. I think inverse of this is very easy. All right, and inverse of this. My difficulties, the difficulties of the problem here, how to find Laplace transform inverse, of e to the s squared over s cubed. For me, it's the first time to see similar to this inverse. For me, always I have e to the s or e to the t, not s squared. I didn't deal with s squared at all. So this term is very complicated term. I'm not sure what I'm going to do now for it. Yeah. Let me remember one rule. I think in second lecture of Laplace transform, we studied the following theorem. Let me write it in red here. In red, I'm going to write the following rule here. We studied this rule. Limit of f of s. When s tends to infinity, it must be what? Do you remember? It must be 0. It's a rule. This is the rule. Let me check if this rule will help me and enforce me to use specific c. Any f capital of s must be 0 when your s tends to infinity. I'm going to check now. If limit my y capital when s tends to infinity, I need this one not to check. This limit must be 0. And any terms not 0, I'm going to cancel it out. I will repeat. This limit must be 0 using this formula. And any term of y, any terms of my function y capital isn't 0 when s tends to infinity, I must cancel it out. Let me check with you. Now, I have two terms, 1 over s power 3. Could you please tell me this term when s tends to infinity will go where?
0.
0. Great. Second term, I have c e to the s squared divided s to the power 3. Don't care about the constant. Don't care about the constant. This term, when s tends to infinity, will approach to where? we have to check how to find this limit
I
e
think
to
it's
the s.
infinity يا دكتور.
Repeat.
I think it will be infinity
Infinity. Why it is infinity? You are right, but why it is infinity?
because the numerator goes faster than the denominator.
Great, Selma. Great, excellent. So Selma said, Professor, in my numerator, I have exponential function. In my denominator, I have a small polynomial. The exponential function is faster, will arrive to infinity first. So my answer is infinity. For those who don't like to deal with this, with the infinity similar to what Selma said, you can use L'Hopital rule to find this limit. Use L'Hopital 3 times and you will find your answer infinity. Now, unfortunately, this term isn't 0. You should cancel it by using its coefficients to be specific number. Could you please tell me the value of C which will cancel this term?
0.
0. C equals 0 must. Why? Because I need the limit to be 0 and this one is infinity. I don't need it to cancel it. I'm going to choose my C to be 0. So now my Y capital, that will give me my Y capital, is given to be only 1 over S to the power 3. That will give me, take third step, take inverse. So Laplace inverse of Y capital is given to be Laplace inverse of 1 over S to the power 3. And that will give me Y small of t. The solution of my differential equation is given to be, what do you think about this? I forget. I need help. Your help, please, to find the inverse of this function.
T squared over
half t
2.
square.
T squared?
Half t square.
Half t squared. Yes, you are right. Using the rule which said Laplace inverse of factorial n divided s to the power n plus 1 is equal t to the power n. So I missed the 2, so I multiplied and divided by 2. Any question here?
Well, doctor, there's still another part to it اللي هي بتاعت 2 over s صح؟
2 over s? What is 2 over s?
يعني الايكويشن اللي هي عشان it was there's on the right hand side 2 over s ولا how we combined it in one equation.
No, I didn't. And where is 2 over s? In
Can
which
you
line?
go back- Can you please go back اللي هو a slide or two
Yes.
to the original equation?
Yeah, here.
ايوه yes the 2 over s بقى اللي هو equal to 2 over s احنا we didn't
Which line? In which
the
line,
last one,
Abdulrahman?
يعني to the left on the left the half side يعني on the left the last
Here.
slide the last line بقى
Yes.
2 over s احنا we used it as the linear equation صح يعني ضمناها على
No.
linear equation.
Just 1 minute. Can you see the array here? I come here. So this line, this step, I wrote after it this one. Am I right here?
يعني we used all of it as the linear as the first order linear صح؟
Yes.
The whole
Yes.
equation.
So I convert it into first order linear. So no need for this to s. Here I didn't use any substitution. Okay, this 2s, it will be negative 2 over s squared, and I solved it using my f. So this 2 over s, it is my f, or built my f. This is your question, Abdurrahman?
Yes, I understand now. Thank you, doctor.
Yes, welcome. What do you think about this problem? Do you have any question? Please, Laplace transform, for me, to be honest with you, maybe I forget when I was a student how did I study the Laplace transform. But when I start teaching at AUC, actually the Laplace transform isn't easy for me as a doctor. So I received my PhD, then after 3 months maybe I start teaching Laplace transform, and I found it isn't easy. It need a lot of practicing and solve a lot of problems to find it very easy for you. Okay, but after that, after solving a lot of problems, and also for me, usually I don't try to memorize the rules. I usually write my cheat sheet and use it to solve maybe 10 problems. After that, so I feel that I memorized all the rules. And also I advise you to do that. Laplace transform is very important for the final. So please try to practice and to finish all the lectures which we studied during this week, tomorrow and on Saturday. Any question? Now let us check how to use Laplace transform also to evaluate some integrals. So Laplace transform helped me to solve differential equations and initial value problems, and also Laplace transform will help me to evaluate some improper integrals similar to this. So now, using Laplace transform, I'm going to evaluate this integral. By the way, if you need to evaluate this integral using integration by parts, maybe you need 2 hours to reach this integral using integration by parts. But now, using Laplace transform, look how we can find the final answer in 2 minutes here. So let me write my t squared e to the negative t. So you need to find the integral of from 0 to infinity t squared e to the negative infinity e to the negative t, sorry, sine 3t dt. I'm not asking you to use to apply Laplace transform here. I need you to evaluate this integral, but please, I give you the hint and I advise you to depend on it. Use some properties of Laplace transform. If the students say, Professor, take Laplace for this integral. No, I usually take Laplace for an equation. Now I don't have an equation.
So we will change it to d square over ds square et to the sine 3t.
Yeah. Yes, you are right. But let me explain this idea in details for the students. Thank you very much, Muhammad. Excellent. Look, Muhammad, what Muhammad said, he told me, Professor, I can write this integral as the following. It's from 0 to infinity e to the negative t times t squared sine 3t. I didn't do anything here. Only I multiplied t by sine, t squared by sine. And also, Muhammad, remember, I'm going to write here down. Muhammad said, Professor, look to this integral. So Muhammad suggests a new integral from 0 to infinity e to the negative st t squared times sine 3t times sine 3t dt. Can anyone of you guess what is this integral? Do you know the answer of this integral? It's very easy for you.
Plus
Repeat, Salma.
Plus of f of t.
Laplace of t squared sine 3t.
But doctor, how will we get the Laplace of t squared sine 3t?
Now we will check. Give me 1 minute. I need to explain this step more for the students. So now, if you have the integral of from 0 to infinity e to the negative st times here anything times apple of t times apple of t dt is given to be Laplace transform of apple of t. This idea which I applied now. So Salma asked me a small question, Professor, we understand this step, but now how to find the Laplace transform of this product? How to find? So please use another color and help us, tell us how you will find the Laplace transform of t squared times any function, not necessary f of t.
I know you, doctor.
It's a rule. It's a rule. T to the power n is given our today rule. Negative 1 to the power negative 1 over to the power n. Sorry, nth derivative with respect to n of Laplace transform of my function f of t. Okay, here rules. Here our rules, which we are going to use. Now, so we understand, Professor, that we need to you need to use this. But unfortunately, here you have S, but up we don't have S. What is the S here? What, Selma?
I have a suggestion.
Yes.
We can use the same idea, but it won't be like this. It will be t squared times e negative t sine 3t, where f of t is going to be equal to negative t times sine 3t, and apply to the easy group.
Could you please repeat again, but slowly, because your voice isn't clear.
We're going to the same idea. It's going to be t squared sine 3t times equal negative t. It's Laplace of e negative t it's the same rule, the one in red.
But unfortunately, also at that time you don't have S.
لا بس I have t squared times e power negative t times sine 3t. It is going to be f of t.
So all of them you're f of t.
لا e power negative t times sine 3t.
And t squared in the first.
Yes.
So you have integral of t squared times exponential times sine.
Yes.
Okay. And then can you consider this as Laplace transform? No, for me, no. Laplace transform need exponential st.
We will it will be negative 1 power 2 بقى Laplace.
No, Selma, no. I need to see before I apply this rule in red, before I start applying this rule, I need to see the Laplace. And here you have only integral. I can say my integral, it is Laplace, but if I have exponential st, negative st. If you don't have exponential st, you can't say that your integral is Laplace transform.
Okay.
So my problem now, where is the S? Here. I have exponential, but with no S. With no S. So let me consider here, my S is 1. If I choose, this S is any number. It's a real number. Let me consider my S is 1. So this, if I choose my S to be 1, so the yellow integral, this one, it's given similar to this rule. It is Laplace of t squared sine 3t, but my S is 1. What do you think? So this integral is the same of this integral. In the special case, is my S is 1. Is it clear, this step? What do you think? Any question, or can I continue? Let me continue. So equal. Now, Laplace of t squared sine 3t is given by this formula. It is negative 1 squared, second derivative with respect to S, of Laplace sine 3t. Sine 3t. Don't forget, in this specific case, my S is 1. Equal. I'm going to write here. Second derivative, d over ds squared of Laplace. No, I know the Laplace of sine 3t. It is 3 over s squared plus 9. Don't forget, your S is 1, which is given to be first derivative. I'm going to differentiate. Differentiate up times down 0 minus 2s times 3 divided by s squared plus 9 all squared. Don't forget that your S is 1. Equal. Now second derivative. Second derivative, it will be negative 6 here, because 2 times 3. Am I right? So negative 6 times the same bracket down, s squared plus 9 all squared, minus, and I have minus, it's a plus 6s. Those are the first, and the derivative down, which is 2 times s squared plus 9 all times 2s times 2s. This, it is s not 5 divided s squared plus 9 all to the power 4. Don't forget that your s is 1. Equal. Now I'm going to write 1. Negative 6. 1 squared 1 plus 9, it's 10. So 10 squared plus 6 times 1, it's 6 times 2 times 10 times 2, because my s is 1, all divided by 1 plus 9, it's 10 to the power 4. You can use calculator to find the final answer. Is it clear? It's need to practice. Let us continue. Now, last thing in this lecture, and actually I'm going to explain the idea here because I need it in the coming lecture. First of all, I need to write here simple things. I think all of you know that if my function f t is given to be sine of t plus 7t squared, and my function g of t is given, let me say, e to the t. Can I ask you how to find f of t plus g of t? This operation between the two functions, it's very easy, professor. You will write sine t plus 7t squared plus e to the t. It's very easy for us. What about if I ask you to give me this operation between those two functions, f of t times g of t? Also, it's very easy for us, professor. You will write sine of t plus 7t squared times the gt, which is e to the t. And then inside this, so it's given to be sine t times e to the t plus 7t squared e to the t. Any question about those two operations? How to add two functions and how to multiply them by each other? It's very easy for us. We call those operations between two functions. We have subtraction, we have division. Those are 4 operations, are very easy for the students. And all of you know how to deal with them maybe from secondary school. In today's lecture now, in this slide, I'm going to define a new operation. It isn't a product, but maybe some books you will find in it, it's a general product. For me, I prefer to call it convolution operation. Convolution between two functions. Okay? So the new operation between two functions, we call it convolution between two functions. If I have function f and a function g, both of them piecewise continuous functions, the convolution between them, it is f star g. It isn't dot, it isn't a plus, it's a star. So if you have a star between two functions, that means you have convolution. How to find the convolution between two functions? Using this rule. If you have a convolution between two functions, so you need to take the integral from 0 to t. The first function with a new variable, tau. The second function after shifting it, t, which is here, minus your new variable times d tau. And your integration now with respect to what? Here, this integral with respect to what? This integral with respect to what?
Tau.
Tau. With respect to tau, and t is constant now. Okay? Did you get the idea of the new operation between two functions? By the way, I'm going to study this operation because I need to use it to find the solution of integral equations in the coming lecture, not today. Now let us find this convolution. It isn't a product, it's a convolution. In the coming slide, together, we can do that. So I need to find this convolution together. It's very easy for me. I have a specific definition. It's given to be integral from 0 to t. First function, which is e to the a, change your variable to be tau, times. The second function, e to the b, you have to shift here t minus tau, d tau. This is the definition. Now I'm going to simplify my function here by multiplying the b inside. So I have integral from 0 to t, e to the a tau times e to the bt times e to the negative p tau, d tau. Don't forget, you need to find the integral with respect to tau. So this one is constant. Take it out. So I have e to the bt integration of from 0 to t, sorry. Can I write those in 1e? Yes, and take tau common factor. So it is e to the tau a minus b d tau. Any question here? How to find this integral? How to find this integral? Is it difficult or very easy?
Easy.
Easy.
Will
How
be
to do
the
integral?
exponential over a minus b.
You are right. So it is 1 over a minus b times the exponential tau a minus b. Don't forget your limits from 0 to t. Yeah. Anyone need to say anything now? This is tau. Let me write it correctly. Anyone need to say anything now? Before plugging the t and 0 instead of tau. What do you think about the denominator? What do you think about the denominator? What about if a equal b? What about if a equal b? Your denominator will be 0. Impossible to let the denominator to be 0. So I'm going to choose my a not equal b. Professor, if my a equal b, so here I'm going to write if the a equal b. So this integral, it will be e to the pt integral from 0 to t. My a is b, so I have e to the 0, which is 1, so I have d tau. And now, so this will be e to the bt times tau from 0 to t. A plug in, so equal e to the bt times t. This in the case a equal b. But in the case a not equal b, I'm going to continue here in yellow. So equal e to the bt divided a minus b bracket e to the t times a minus b minus e to the 0. Am I right? E to the 0, which is 1. This is the answer of this convolution. Let me do this one also. Any question about the first one? No questions. Here, the convolution is given to be integral from 0 to infinity. The first function, e to the tau. Second function, after shifting it, t minus
Doctor,
tau.
from 0 to t.
I'm so sorry. I'm going to write it. d tau. So it's integral from 0 to t. The definition of the convolution, you will write the definition in your cheat sheet. How to do how to integrate a product between two functions. One of them is the exponential and the second is trigonometric. Do you remember how to integrate this function? Speak please. How to integrate the product between exponential and I'm going to use the integration by parts. Let me use this to be u and this to be dv. So my v is what? And my du is what? My du, it is e to the tau d tau. It's very easy for me. Here my v, it is, what do you think? It is cosine t minus tau. So the rule said u times v minus integral of vdu. Let me go back to the yellow and plug in. And by the way, don't forget, always if you have a product between exponential and trigonometric function, you need to integrate it twice by parts. So equal, let me write here.
دكتور
Yes.
مش ال V هتبقى نيجاتيف كوساين؟
And you have here negative. Right?
اوكي.
Yes, great, Islam. So my u, it is e to the tau. My v, it is cosine t minus tau from 0 to t. minus integral. My v, it is cosine of t minus tau. My dv, it is e to the tau, du, sorry, d tau. From 0 to t also. Equal. Let me plug in here. First t. So here I have e to the t. Help me please. E to the t. And here cosine t minus t is the cosine 0 is 1. Great. Minus. Now I'm going to plug in 0. So e to the 0. E to the 0, which is 1. Cosine t minus 0. So it's cosine t minus. How to integrate this function? How to integrate this function?
By box.
By parts again. Let me go to the blue. This is my u, the same, and this is my dv. So my v now, my v, it's negative sine t minus tau. So I'm going to write here the integral. So negative bracket u times v, which is e to the tau times negative sine t minus tau from 0 to t minus. You have minus here and this minus, so it is a plus integral from 0 to t. Your du, it is e to the tau, and this is sine. So e to the tau sine of t minus tau d tau. What about of last integral, this one? Look to the last integral, please. This one. How to do the last integral?
It is the same.
It is the same like this one. It is the same of the original one. So I'm going to call it I. So this is I. So now I have I here equal e to the t, which is this, negative cosine t, which is this, negative and negative. Let me write the negative bracket. Now plug in the t, so negative e to the t, and sine t minus t, it's 0. Sine 0 is 0, cancel out, so negative. Now the 0, so negative 1, negative and negative, it is a plus. Sine only t. Here I have a plus I. Inside the negative. So you have minus I. Take it to the left hand side. So you have 2I. Am I right here? Because this negative will be here. Take it to I. Equal e to the t, negative cosine t, negative sine t, sine t. That means your I is equal half of those e to the t cosine negative sine. So you found the convolution between those two functions. Is it clear? So do you have any question? I finished.
Thank you, Doctor.
Yeah, so we can meet at 1 o'clock, but please, Laplace transform need you to practice. And don't worry if you need to watch the video more than one time, okay? But you have to practice a lot to feel the Laplace transform very easy. Okay? And if no question, I hope you have a great day. We can meet at 1 o'clock if you need to discuss the worksheet together.
Thank you.
Thank you.
Welcome all of you.
Okay.
Welcome. Bye all of you. Goodbye.